a part where
I'm listening. Continue.
okay, I think there was a part when the video cut and you joined the next one to it. I saw something like X plus plus
Okay.
as a shortcut of writing X plus one
Yeah.
and also minus minus, something like that.
Yeah.
Yeah,
Can you see
at
my
some
screen?
point, yes. So, yes.
Mm.
This A minus minus scrolling up to now. A is equal to A minus one. I didn't really get what was said around that because I was not in the class and the
Okay.
video
Okay.
didn't talk about it.
Okay. Okay. I was saying that this line 62 is the same as line 60. If you need to reduce a variable by a unit, that's one. Instead of going ahead to write it this way, you can equally write it this way. For instance, for example, let's I've declared this variable. A is 20 here. On line 57, A is 20. And along the line in my code, I want to reduce A. Now, we said that for let, you can reassign a value for let. This let A, because I use the let assignment pattern, I can reassign it to another value. So in line 60, A is now equal to the same A that I had here before, minus 1. So I'm reducing A by 1 in line 60. So instead of writing it this way, I can go ahead and write it this way, A minus minus. Just for unit reduction, that is if I'm reducing by 1, that is the only time you apply this. This code, line 62 and line 60 are the same thing. If I console log, okay, let's console log A, line 62. This is line, let me comment out the other lines. Comment out the other lines. Okay, so on this line 62, in line 60, let A equal to 20. I'm declaring A as 20. Well, we all know what variable declaration is. I'm declaring A as 20. So if I console log A, I'm supposed to have C20. Am I right? Now,
Yes, sir.
okay, okay. So this is my console log. So this is 20. So I'm getting 20 here as my A, 20 as A. Now, if I go ahead and change, now in line 60, I want to now change the value of A and reduce A by 1, which means that I'm reassigning a new value to A. This A is a new value in memory. That what it does is that the same A I declared here as 20, in this place I want to reassign it. But don't forget that the last value for A was 20. So if I now come here and reassign A, I say A equal to the same A I assigned before minus 1. So instead of writing it like this, I said we can do it the way we did it in line 62. I'm reducing A by a unit, which is 1 by 1. So this expression and this expression are the same thing when it comes to a unit reduction. So if I do this now you can see that on line 62, A is now 19. Because after I declared it as 60 here, I now changed it to, I reduced it by 1, which is 19. So if I don't want to write it this way, I can go ahead and do it this way. I'm saying the same thing. The same thing applies to plus. Plus, if I want to increase value of A by 1, I want to increase the
Okay,
value.
I understand, sir. But what if you want to increase beyond a unit? I want to
So
decrease beyond the unit. Are there cases where we need to do that?
yeah, there are cases where you need to increase or decrease beyond the unit. So you have
Yeah.
to write it like this, not like this.
Okay. Okay.
So yeah, you only use this when you want to increase or decrease by a unit.
Okay, sir. Then I saw on your lesson outline, that's the objective what we're supposed to cover. I saw greater than or equal to, greater than or equal to, less than or equal to. I didn't see where that was used here.
Okay, let me see.
And we covered it.
I think we used it somewhere. We used this. I think I used it before then. But let me just go through it. I think we're trying to look at uh we're trying to look at conditionals, and we used it as an example here when we use the if statements. You see, the if statement renders things according to some kind of condition. And now we are saying that we've declared time as 19 here. Let's say on line 125, we said if time is less than 12, the greeting should be, we should consider good morning. Now, but if time is equal to 12 or time is less than 18, it should be good afternoon. And if time is or else for any other value, which means time greater than 18, it should be good night. Then we can use that greater than or less than in this case. If time is, okay, so if time is less than or equal to 18. So let me, is less than or equal to, okay.
That assignment, is it not say ambiguous? Because when you say less than 18 will still
That,
be before 12 o'clock.
yeah, so we can remove this one here and refer to only one statement. That is, can say you can remove this if statement. Can now remove this one because that time covers for even 12.
Yeah.
You say so if this is where you use it, we are saying time is less than or equal to 18, do this. And if time for any other time greater than 18, do this. So this is where you use the greater than or less than sign. If you don't want to start expressing it separately, you can use greater than or less than in this way. Just the same way we apply it in maths. So JavaScript
Yes, sir.
understands that this thing means either this time is less than or is equal to 18, do this.
Okay, so could you write something like if time is less than or equal to, if time is greater than or equal to 12 and
Yeah.
less than or equal to 18, will he really respect, will he observe the time? Because when you say time greater than or equal to 12, okay, and at the same time, use and as the double and symbol,
Okay.
and less than or equal to 18, will he really give us the afternoon range?
Okay.
Because
If
I
you
think if
say,
we write that,
so you're trying to say if the time is between 12 noon and 6 p.m. Is that what you're
6
saying?
p.m., yes.
Okay. If you want to do that, you can say if the time is greater than. Okay, I understand
Or
what you're
equal
saying.
to 12, yes.
Let's see. Let me go back to where it was before. So if the time is greater than.
Or equal to 12 and less than. Like that and there, is it really, because in mathematics, that's what happens. Once you state that, it means that
Yeah.
you're going to have an inequality with boundaries.
Let's just practicalize it. But that's what it's actually the same. You know, here we use or. We use or here. This stands for or. Now, what
Yeah,
this does is, what and does is, if the time now is greater than 12, let's go ahead and check it out. If it's
okay,
greater than
greater.
12, it's greater than 12, and it is it is less than 18. So you can use
Yes,
a double amperand sign and less than 18. Great good afternoon. So if we change this out, so this our time, this one now is good night because it's modern. So if we change this time to say 14 and see what gets. Okay, I still have this here. Change this to 12. So we have good afternoon there because the time is between 12 and 18. So what this amperage, the way it works is if this first value is true, if it returns a true, it will now go ahead and check the second one.
Check the second
But
value.
once this one returns a false, it will break. It will not go to the second one. Already, for the whole statement here to be true, it knows that the two of them must be true. So once the first one has failed the test, that it doesn't check the second one again. That's one thing I want you to note about this ampersand sign. Meanwhile, the or, if the or does, if the first, whether the first one fails or does not, it will go ahead and check yes. But the and, because you need a lot when you want to do some evaluations. But the and, once it checks the first one and it evaluates the first, it will break the code. It will not check the second one. It will just jump to the next statement. So if well, what we had before was okay, less than 12, good afternoon. If the number we had here was 20, 120, for instance, if it's 120, see, it will not run this. Once it checks this first one, it doesn't go, it will just jump to the next code. So what it does is it will check this one. If it doesn't work, it jumps. Now it will check this first part of this code. It will not check this one. Once it is false, it will just jump to the next code. It doesn't need to check this again. That is how
it works. Thank you, sir. Please, could you just put equal to around that second else if, okay, time is greater than or equal to 12 and time is less than or equal to 18. I just want to check something. Now, if you put the boundaries 12 or 18, what will really come out?
It's the same thing. If you say equal to 12, time is...
greater than or equal to. No, not directly the way it was before. But
greater
then
than or equal to 12.
Yes. And also less than or equal to.
In the same logic.
And then less than or equal to 18.
It will produce the same logic.
Okay, then maybe
because
change
it's still within the boundary.
Oh.
It's still within the boundary.
Please put exactly 18 there.
If the time is it's less than 18, why is it giving us good morning? Less than 12. No less than 12.
You need to refresh. It's showing good afternoon now.
Yeah, it's reading this one as well. Yeah, no, we said if the time is less than or equal to, so it's correct now. It's good afternoon now. We said if it's equal to 18, it should be good afternoon. I guess it's because I didn't refresh before.
Okay. So that means also if you put exactly 12, it's still gonna be afternoon. No problem, sir.
Sure.
Thank you.
You can go ahead and try these things and check them. Okay, so any other questions? Lucy, do you have a question? Have you gone through the other things? Do you have a question?
I have not gone through I'm yet to go through it. I was downloading it early morning to go through it, but I had issues. So after this class, I will download and then go through it. But are you trying to solve a question?
No, we are trying to see. Last week we talked of rendering things conditional using the if statements. That's all. But just go through the video.
Okay.
I think it will be clearer to you. Let's do functions today.
Okay.
Functions and
continue.
Yeah. All right. So we're looking at functions today. This time. Okay. So functions are basically functions they are just like, what do I call them now? They're like in JavaScript, they are used to make sure we don't repeat code. If there's one thing we do when it comes to programming, is one principle called do not repeat yourself. It's a very well-known principle. And it is said that we don't want to repeat lines of codes. It's not the number of lines of code you write that makes you a good developer. One of the good things they check is the amount of space you can save. Now, what functions help us to do is they help us to arrange our codes in such a way that we can reuse them in our app. It's like you take a block of code that does a particular thing, and you can reuse them in different parts of your app. But one good thing is you call the same function, but it will give you different results for different scenarios. Now, it's expressed like this. This is syntax for writing functions. But just know that functions are a block of codes that can be reused severally in your code. That you can call them in different parts of your code without needing to rewrite the whole block of code again. When I mean a block of code, like this is a block of code. This is a block of code where a block of code solves a particular problem. So this code solves this problem. This is a block of code. So instead of me writing this thing over and over again, I can do it in such a way that I don't need to repeat this thing over and over again. For instance, this is an example of a function. This is an example of a function. This is an example of a function. Now, what I want this function, this is what I want. Let me delete these things first. Let me delete this first. This is what I want this function to do. I want a function that, for now, I just want the function to display, okay, display console.t. Console.t. Now, the syntax of function is, it's written like this. The word function is used. Then this is the name of the function, timer. The name of the function in my case is timer. And anything inside the brackets after the name of the function is called the function parameter. You can have one or two parameters. You can have multiple parameters, several parameters inside of. I can have another parameter called x. I can have another one called y. You can have several parameters inside your function. Now, this now is the execution, the function execution, what the function does. This my function now is a function that I want to console.t. Well, let me say I want a function. Let me do another function that makes a little bit of sense. Let me say x and y. I want a function that multiplies two numbers together. Let me call it a multiplier. I want a function that multiplies two numbers together. So this is what the function does. Then inside the function, there is something called the return keyword. Return means what the function produces at the end of the day. Sorry, I say multiply. So let's multiply, the symbol for the operator for multiply. So what this function is doing is that I'm saying multiply these two numbers and return the answer of these two numbers. So this is the function. But if you check my console, the function, I have declared it, but I haven't called it. I can declare this function anywhere. I can declare it in the topmost of my page. Then in different parts of my page, I now have to call it. There's something called calling a function or invoking a function. The word call or invoke. Use the word calling or invoke. Invoking a function. Invoke. Either you say calling or invoking a function. Now, after declaring this function, I can now go ahead and call this function in anywhere in my app. For instance, I now come here, I call the function multiply. If I call this function multiply, see what this function does. Okay, see what this function does. Now, don't forget that I pass two parameters to this function. If I pass two parameters to this function, the function expects me to pass this line 88 is called calling the function, invocation or calling the function. Calling function. After declaring the function, you have to call the function. This is where I declare the function. Using the function keyword, this is how we declare a function. There are other ways of declaring, but we'll look into those This is how you declare a typical function. Then this is how you call the function. You call it by calling the name of the function. Remember I said this is the name of the function. And these are the parameters of the function. You now pass the number of, you now pass something we call arguments. Now, the number of arguments you pass after you name the function should be equal to the number of parameters that were passed into the function when you were declaring the function. Because I have two parameters here, I have to now pass two arguments. Here we call it an argument, here we call them parameters. So if I pass in 40 and 2, and I'm saying it should return this thing, well, for us to see what we are doing, we have to use console log. Let me put it inside a console log statement so that we will see the results. The results. Okay. Now this is what has happened. On this is my line 141. You can see here from my console, script.js line 141, I have 80, which means that if I want to call this multiplication, I can call it in anywhere in my app without necessarily need to rewrite this function for everywhere. Like if I come down here and I call it again, I can call it again here. Pass different arguments to it. This time around, I pass 202. I get my answer. 202. Okay, sorry, yes, round 4. 202, and I get 400. So I can call it as many times as I want in my application. So what I'm doing here is that this thing is equivalent to rewriting this function here, writing it here, writing it. So imagine that I have to be writing the function everywhere I need to use the function. Imagine I have to be rewriting it. It's a bulky task. But what function help us do is that I can always recall it, any number of times I want to call it. So that is what we do with how we operate with functions. So they can be declared in any way. At the topmost part of your page, you declare them. Then you start calling them after you declare them. And you can call them as many times as you want. That's why I told you that you call the same function, input a different argument, and the answer you get is a different answer. Just as we have here, we have 80 here. For this case, we have 200 and we have 2000 here. Just a little bit of refreshing my page for that to show. That is 2000 there. 2000 there. So this is how functions work. About the function.
No question from me.
All right. Suka, any question?
Listen, I'm not really following the class today. I'll just go through the video later. Hello?
Okay. All right. So as I said, you can call the function in any part of your code. So function is one way of keeping your code dry. There's a principle called dry, and there's a principle called the dry principle. The dry means don't repeat yourself. Dry means the word dry says don't repeat yourself. It's one principle when it comes to software development. We try as much as we can to keep our code clean so that we don't have to be rewriting a particular block of code over and over again. That is one thing we do. So if I now go ahead and repeat this function statement anytime I want to use it, it means that I'm repeating myself. And when I mean use it, I mean that as I console log it here straight, I can save it in a variable. Let's say I do a variable here, and I save the result. I say, okay, in this case, I say M1. Let me just call it M1. I call M1 to be multiply. I call M1 to be multiply. This is my M1. So I console log M1. So I can actually save the return value of the function in a variable, just as what I'm doing here. So you can imagine that I want to use this variable in the future. All I need to do is to save it in a variable and use this to do whatever I want it to do. In this case, I'm just console logging it here. I'm just console logging it here. But there are cases where I need to use it to do something. Let's say I want to use it as a prompt statement and display it and say, hey, show an alert that says the answer of this is this or something. Show an alert or something. Okay, let me say after saving it in this variable. We just repeat this 3 times. I'm repeating this 3 times. Save this one in another variable. Call it 500. I have another one. Another one. Save in the variable. With repeat something. 3. Okay, so I just shift them in variables now. So these are the return values of the function. This means that I want to use multiplication to do something. So I'm getting a different value, I'm getting a different one, I'm getting a different one here. And for example, in M1, I wanted to just console log it, and in M2, I wanted to show an alert or something. So I wanted to show an alert or something. You can do alerts. Alerts. Alert M2, I'm getting it here. So just to show us how functions work, that they are very, very useful, and you'll be using them a lot when it comes to JavaScript. A lot, you'll be using them a lot. JavaScript and in other languages, you'll be encountering them and using them a lot when it comes to JavaScript, when it comes to programming. So this is how functions basically work. And as I said, you can save the result of functions in variables. As I save this in a variable, save this in a variable, save this in a variable. So, and this real return here is actually what the function gives you back. Return means that evaluate this function and return this. So whatever you have in this your return is what the function produces as your final answer. No matter what I have here, let's say I have other things I did here. Let's say I did I say let's I say let's z equal z equal x plus y. Now I've done let's z equal x plus 1 y, but in this my console log here, all I will get is this one that was returned. Because your function, what is returned in your function it's actually like the result of that function call. Is the result of the function call that you made. So that is what is returned in your function. If I do this, I say p equal to x times y, and I return p here. And I return p. Even if I did 2 operations inside my function, I did a plus and I did 2, but what I returned is this. So this is what I will have as the result of this my function call. What is returned? So your return value is like saying this function, after everything that happens in the function, this is the value this function is throwing out. Function is like, okay, like a processor. I've thrown these values inside this processor. Now, whatever is attached to the return is what this processor gives me back as the result of my function. It's what the processor actually dishes out, gives me back as the result of my function. So we now know what function is, so that when you're working and you expect a different result and probably you're not getting it, just give me a sec.
So I can hear you.
Sorry for that. Yeah, I was muted for a while. Okay, so the return statement is actually what your function gives back. Actually shows what your function gives back as a value. That's what the return statement shows you. Now, your function helps to keep your code dry, as I said before, and I also said that this whatever is returned in your function can be stored in a variable and used in any part of your application. So you see the importance of function. This is where you declare the function, and this is where you call the function. So this is basically what we need to know for now about function. The only thing we might need to now also look into is how functions are declared. Okay, but before that, I just want to point out something. Now, there is something called scoping when it comes to JavaScript. Scope means that because these are just some principles I want you to have notes down, so that when you're working with JavaScript, if you encounter problems, you know how to tackle them. Now, if you notice, this my z is declared inside of my function statement. It means that if I want to console log z outside this function statement, I will get an error. Because my z is actually locally scoped to my function. What do you mean? My z is a local variable. The word local means that it is local to a particular function. It is local to a particular function. It is not we have things called global variables and local variables. In this my case, this z is a local variable. So if I try to console log z is naturally supposed to give me x plus y, which is x plus y or anything I call something. Okay, let me say, okay, without even calling, let me use another example, sorry, to understand it better. Let me say, let m equals 40. Let m equals to 40. So if I console log m here, it will throw back an error. See the error, it's saying, compute error, reference m is not defined. Even if I define it inside this function, it's saying it's not defined. Why? Because it is defined locally in the function. So it is called a local variable to this function. Now, variables that are global variables are not declared inside of a function or inside of a block. They are declared globally. Like if I declare it outside here, it now becomes a global variable. Global means every function, every argument, everything can actually use this variable for whatever kind of operation. Here, if I declare it as 40, it is now a global variable. It is now 40 here. It is now 40 here. Let m equal to this, and I say, in this case, I now come here and say m equal to let's say m equal to 60. Let's see what happens. See, it's still returning that m is equal to 40. Why? Because it doesn't have the right to touch what is inside here. The only thing that happens, the only thing we can do with what is inside here is whatever is returned, what is spilled out. That is what we work with. So that is how function works, and that is how they operate. We can have multiple parameters passed into a function. I can pass another parameter called u, but make sure that when passing the argument, you pass, if you want it to return a result, this case now, let's see. Okay. Okay. It's returning 80. Now let's say I want to add u here. It's returning not a number. Why is it returning not a number? It's returning not a number because there is no argument passed to u. So u is not a number. So you can't multiply 2, just as you are saying, just like saying 20 times oranges. You can't give you, it's not equal to oranges, it's not equal to numbers. So it's not a number. So if you want to get an accurate result, make sure that the number of arguments parameters that you use in declaring a function is equal to the number of arguments passed to your function. So if you do this now, you get the accurate answer. That's the intended answer. That's for function. Then another thing I want us to also look at is there are function parameters can have default values. you can declare default values for function parameters. Let's say I come here and I declare this u to be say 100. I declare you as 100. If I declare you as 100, even if I remove 5 here, I still get the answer. Why? Because u is already permanently declared as 100. So anyway, I call u, even if I don't pass in the 3 parameters, this is the only case where you might need to skip some parameters because you've already declared it in the function declaration. So JavaScript understands that this one is already has a number. So I'm expecting just 2 other arguments to make this work. But once I now declare an argument here, it now overrides my default argument. What this default argument does is, in case it is not defined, please use this number. For example, if you look the case of M2, I didn't define it in M2. It will now use that number in M2. It will use that number in M2 to console M2. So if we now look at it, M2 becomes this and M1 becomes this. So in M2, I did not pass the third parameter. I did not pass the third parameter. I did not pass an argument to the third parameter. So that is why it's now taking the default params and using it to do whatever to evaluate the expression. So that is how functions work. They can be very tricky, but very good to know and very straightforward to understand. Having said that, we've declared our functions like this. There is also another way of declaring functions. You can also declare function in another way. ES6, don't need to bother yourself with what ES6 means for now. We'll look into that and proceed. It's just a version of ECMAScript. Sorry, ECMAScript 6 is like a version of the language. It evolves from one part to the other. There are just rules guiding the language. So if a new rule comes out, a set of new rules comes out, they fall under ECMAScript, give it a number, something like that. So beginning from a particular year, I think 2015, there was another method that was introduced used in declaring functions called the arrow function. The arrow function. The arrow function. The arrow function. It does the same thing with the function. The only difference it does is that it simplifies this declaration. Now, instead of going ahead to write function first, we can go ahead and do like this. We write the function name as if we are declaring a variable, but this time using an arrow. We write the function name and we say we now pass the arguments. Pass it the arguments. Then we use this arrow. That is why it's called the arrow function. We use this arrow. Okay, so now we don't need to now write the return statements. Go ahead and write it this way, and it will do the same thing. Say x times y. X times y. So if I come down here and I call it like console. I come down here and yeah, I already declared it. Return. If I come here and declare sum, 156. Okay, undefined. Be very careful with curly braces when it comes something about. Yeah. So this is how you declare the arrow function. So what we've done here basically is, this is the function name, and this is the same thing we did. This is where we pass in the function parameters, and this is the expression that needs to be evaluated when we pass in those parameters. So this method produces the same result with that other method. The only difference now is that in this case, we don't need to use the function keyword. We don't need to use the function keyword. We don't need to use the return keyword. We simplify it by declaring it like this. So this is how we declare it using the arrow function. So is that clear, please?
It's clear, sir. But please, I beg, remind me why we are putting const in front of those things.
Why we are putting const in front of what?
In front of the sum, in
can
front
use
of
let.
the M1.
You can use let if you want to use let. We want to save it in a variable so that it can be used later. So instead of going ahead to call this long line, I've already saved it in M3. So anyway, I want to use it in my code, I just call M3.
What if I don't put the const? What if I just write M3 equal to?
It will not work.
Or after your arrow function, I'll just write sum equal to.
Now you're getting these things confused.
Okay, you know, at the beginning video, I really missed the video.
This is where we started. We said in JavaScript, if you need, I gave an example and said you're doing a particular operation. Okay, you know how you do in maths that you say let A equal to B, let B
Yes,
equal.
I know maths.
Yes, because you need to reuse these things. If you say let A equal to, okay, let's say you give a definition, say there are 40 students in a class, 20 are boys, 20 are girls. Those things now, you have to now break them down and say, okay, let the number of boys be X and let it be equal to 20. Let the number of girls be X and let it, it's like you're collecting that expression and you're storing it in a variable that you use later. So just as we did here, we collected the expression called 20 and we saved it in this variable called A. This variable is like a space in memory that JavaScript creates. That's okay. Whenever you see A in this code, it stands for 20. Now, the only difference is that we say when we use let, we say that thing we stored in memory can be changed. It can be changed, it can be mutated. But when we use const means constant, it cannot be changed.
Okay. Thank you so much.
Yeah. So in this case now, I'm using const there. It means I cannot do M1 equal to this. It's already, if I do it, throw an error. Once I say M1 equal to M1, if I say equal to 2, to tell me that assignment to const variable at this, I've already assigned, it's like M1 is an unchanging variable. It's a variable that cannot be mutated. But if I use let here, I can change M1. Okay. I can change M1. I can change M1. Instead of M1 being the product of this function call, it can now just be 2, which is what you're seeing here. M1 is now 2. So what we're doing here with functions is that we're collecting this operation that we do. Function is like you have a machine. What does that machine do? Maybe you have, when you go to a factory, there is a machine that packages. Maybe you go to a factory where they make bread. There's a machine that puts the bread in the baked bread in leather, seals them. What the machine gives you as an output is a bread inside of a bag tied. But what enters into the machine is just bread that is not inside of a leather. So the process of packaging it inside of that leather. Now, funny enough, inside of that machine, there are other things you put in that machine. For instance, you might throw chemical to make the leather strong, you might throw the rope, but the machine does not care. The output does not bring out those things. What comes out is now what it's wrapped inside that leather, which is what is returned to us. So that is the same principle with function. You pack everything, you throw into function, and you tell function, give me something. So whatever you have in your return statement, if you're declaring the function this way, if you're declaring it using the function called keyword, is what is produced from that function. Function is like the machine now. Now, that thing that you produce, because you might need to use it in other areas of your code, you now store it in a variable and keep it safely in a variable, such that you can always call and use it to do any other thing you want to do with it. But if you intend to change it, then you can now use let to save it. But if you don't intend to change it, use const to save it. But when we're declaring function using the arrow function method, it must be const. Please note that you must use const. If you're declaring a function, sir. Yes, this line 158 and line 135 to this point are the same thing. What I did here, the only difference is that, okay, in this case, now let me remove all these other extra things I included here. Let's leave that one. So this line one, these two lines are the same thing. This one written briefly, or for those, there's something called brevity. Of whole like things being short and simple and straightforward. Then if I go ahead and write it this way, move this because we're doing addition now. So sum. So we're doing sum. So these two things. Okay, let me use some sum of numbers. Sum of numbers. Okay. So I'm using sum of numbers here. I'm using sum here. So these two codes are the same. This code and this code, they do the same thing. But this one is shorter and straightforward. So this one is done using the arrow function method and declaring function. This is the arrow function method. And this one is using the function declaration where you use the function keyword. Function expression. Function expression and using the arrow keyword to declare your function. Arrow function method. So this is basically some of the things we should note about function. There are other things we'll be seeing along the line when it comes to functions, but this is basically like the basics. And we'll now build on this, and whatever we want to do, we can do. So any questions based on this function, please? Uzi, you can go ahead and ask your question if you have a question based on this.
Okay, so I'm just trying to, wrap my head around this function thing with Python programming.
Okay.
It looks like there's a relationship between the two.
Yeah, there is. That's why I said you see function in most programming languages, because programmers are lazy people. Nobody likes to type and begin to write long block of code again from beginning. So instead of doing that, there's always a function. So once you write it somewhere, declare it above where you want to call it, you can always reuse it, use it for different parts of your application. Yeah. So
okay, so what we have done now, I know you're just introducing the methodology of the function. Okay. Have we solved a particular problem? Because I'm trying to, because all this is like functions. If you now tell us about the methodology, you now throw a question that is related to this function. We'll now solve it, because I'm just trying to, understand, the first two where you have M1, M2, M3. So I'm now asking myself, is there any question that you are solving on this particular thing you're doing, or you're just telling us the fundamentals of function?
We solved it.
I don't know, just help my understanding, please.
I think we solved the question. See this one. We're trying to write a.
Okay, we are solving a question.
Yeah, we want to build a that multiplies any two numbers or three numbers, especially if we have this, or three numbers. Want to build a machine. What the machine is that it will throw two numbers, give us the value, to multiply those two numbers and return back the value to us. So, and let's say we want to use that, what is returned, to do something in another place in our application. In this case, we have to store it in a variable and maybe console log it or use it to do anything. But the idea is that instead of me going ahead to rewrite this function, this thing, and passing here, we passed 40 and 2. Here we passed 502. Here we passed 520 and 2. Now, if I didn't do this, I will have to rewrite this code again. Rewrite this block of code again. But this time around, I now have to, which means I have to be specific. I have to be passing them these values. If I didn't do this. But what function helps us to do is, I just declare like an arbitrary value using A, B, C. Then here, I now call the function. This is where you call, this is called invoking or calling the function. Like I'm making a call, putting a call across to that function I declared, saying, I want to use you. But this time around, I want to use you using my own variables, which are 502. Meanwhile, M1 says, I want to use the same function, but I have my own variables, which is 40 and 2. So we call them we can call them in different aspects of our app. So that is what function does for us. So instead of going ahead to rewrite or rebuild this machine everywhere we want to do multiplication, we just call this function and implement multiplication. I just want to give you a hint. This is how your calculator app is being built. Each time you type 4 in your calculator app, what you're doing is that you're passing this first value. You type 2, you're passing the second value. When you type equal to calls this function. Equal to will take these two values, put inside there, do multiplication and return the value to you. You now see that display of X, that display of the result on your calculator screen. So what happens inside your calculator is almost similar to what we're doing here. There's a function that does multiplication. There's a function that does summation, which is what we have here. There's a function that does division, minus, and the rest of them. So when you press 4 is saved here. Wait, I just want to make sure I'm recording. Okay, when you now click on 4 is saved as the first argument. You click on 40, it's saved as the first argument using JavaScript, of course. Of course, we'll look into those things, how you can save it when you click it. But I just want to give an idea of how function plays so many roles in programming. So when you put 40, it's stored here. You put 2, it is stored here. You now call the function multiply. The multiply you're calling is when you press the button X on your computer. JavaScript, you program it, of course. You program it in such a way that X means multiply. So when JavaScript sees X, it means that you're calling the multiply function on those two numbers. So it will now, when you now click your equal to, it will now send those two numbers to this particular function. If it's summation you want to do, once you click the two numbers, it will store it for you safely. Once you click on plus, it already knows that it is sum that you want to call. So if you click equal to, it will call this function on those two arguments you just typed on your calculator. That is how these calculator apps you see natural are being built in general. So you see how function plays a lot of role when it comes to programming. Exactly. Are we on the same page?
Yeah.
Okay. I would like to do some. We'll see how we can round off today's class, because I want us to digest this function very well, because it can be very confusing. But before we go, we have less than 5 minutes. Before we go on this, I would like to introduce the subject of arrays. We've basically finished everything about function. Not everything per se, but the basics of function. We're basically done with the basics of function. So please, I want you to go ahead and check W3 Schools, Stack Overflow, read more about functions, get questions about it. I will try my best to get some little things we can solve when it comes to calling functions. Just know how to declare functions and call them, declare them and call them, pass arguments. That is all what you need to know for now, because they play so much role. Even if you go and learn React, just as you mentioned in Python, you see them, but they even just master them to help us a lot. Okay, so having said that, I want to quickly just breeze through arrays before our time rounds up. Arrays. Now, arrays, as I introduced in the last time, it's a type of data, it's a data type in JavaScript. Arrays are not necessarily data types on their own. They are a data type that is under the object data type. It's just that array is very broad, that we consider it as a data type on its own. But in real sense, array is actually a type of object. As I have introduced object before, we'll see it. You don't need to break your head about why and so. Just understand that it's a type of object, but it is being treated on its own. It's just like something grows too big and you don't want to hide it under anything. You bring it out and say, okay, this is a data type on its own. So how do we express arrays? How do we write arrays? You can form an array this way. This is the syntax to form an array. Once JavaScript sees this, it knows it's an array you're trying to create. And the elements of the array can be the elements of an array can be anything. It can be numbers, all separated by commas. It can be numbers separated by commas. This is an array. It can also be array 2. It can also be strings, all separated by commas. Also be string, all separated by commas. Okay, so it can be strings, numbers mixed together just like that, but just the basic syntax for the array is that it's covered in square brackets, separated by, and the elements are separated by commas. So this is how an array, this is one method of forming an array. Now there's another method of forming an array using the new keyword. If I go ahead and declare whichever name you give to your array, whichever name you call, the name is up to you. This array I call, any name is up to you. You just have to follow the convention and make sure you name them right. So I go ahead and say array of things. Let me say array of things is equal to, and I say new array of things. I say new array. So I've created an array, but I created an empty array that does not have variables. So this is an empty array without variable. So if I go ahead and console log this thing, I'll just get an empty array. Console.log. Console. No array of things. So it's an empty array. Why? Because I didn't include it in here. If I console.log the orders I declared, you'll see it's an array that has array 2, array 2. So this one has 3 numbers, 3 elements inside the array, and this one is empty. So after declaring an empty array like this, you can declare it like this, either totally empty, or you can now come here and use the same method to declare an array of animals. Then you now start adding the elements here, say goat, cat, so these are the methods for declaring arrays. Very easy, very straightforward, but can be very, very useful. I have animal is not defined. Animal. Okay. Okay, so I have this one on line 180, which is this. I have this first one that is empty, this one, and this. So this is how you declare an array. I know you might be wondering, okay, this one that's an empty array, how do you now populate it with variables? How do you now populate it with variables? Let me see if we have less than a minute. Okay, so for today, I've introduced you to arrays and how to declare arrays. And also, we also did functions. I would like to end the class here and want you to look at these things again. And if you have questions, please within the week you can reach out, or within the week you can reach out. Hopefully we'll be there to answer. All right, any further questions?